An object oscillates with simple harmonic motion along the x-axis. Its position varies with time according to the equation. X is equals to 4.00 meters times cos in brackets pi t plus pi over 4, where t is in seconds and the angles in the parentheses are in radians. A. Determine the amplitude, frequency, and period of the motion. B. Calculate the velocity and acceleration of the object at any time t. C. Using the results of part B, determine the position, velocity, and acceleration of the object at t is equals to 1.00 seconds. Then D. Determine the maximum speed and maximum acceleration of the object. So solution, we start with A, solution. A asks us to determine the amplitude, frequency, and period of the motion. The trick for part A is just to know the general formula that for an object that oscillates with simple harmonic motion, that relates the position x and time, and that the general equation is x is equals to a cos omega t plus psi. Are we there? This is the general equation. This A is for amplitude. Are we there? This is the omega t psi. So we compare this equation with the equation given in the question, this one, so that we have been asked to find the amplitude. So our amplitude, if we compare this equation, the given equation is x is equal to 4.00 meters cos pi t plus pi over 4. It's just like we are matching. So amplitude A is equal to 4.00 meters. Just amplitude, and omega is equals to pi rads. As we can see, here is omega t, here is pi t. So omega is pi is equals to this omega is equal to pi rads. Therefore the frequency is given by omega over 2 pi. So the frequency will be pi over 2 pi. We have just substituted this omega with pi. Are we there? So that the frequency gives us 0.500 hertz. Okay. The next thing is the period. Remember, period is equals to 1 over frequency, or frequency is equals to 1 over period. Are we there? As in, period and frequency are inversely proportional. So period will be 1 over 0.500, which gives us 2.00 seconds. Are you there? Part B is calculate the velocity and acceleration of the object at any time t. Solution. Here, to calculate the velocity and acceleration, we differentiate x the displacement, we differentiate this equation. So with respect to dt dx dt of 4.00 meters cos pi t plus pi over 4, we differentiate the displacement to get the velocity, and then we differentiate the velocity to find the acceleration. So we start by differentiating the displacement to find the velocity. Here we apply the product rule for differentiation, both the product rule and the chain rule. So it is dx dt of 4.00 meters cos pi t plus pi over 4 So we apply both product rule and the chain rule. So the product rule from calculus, product rule, it states that u dv in this case now dv dt, in this case dv dt plus v du dt. So from this expression for displacement x, let's take u to be 4.00 meters, then v to be cos pi t plus pi over 4 plus pi over 4, so that du dt is equals to 0 when differentiate 4. Remember, differentiation of when differentiate a constant, we get 0. Then dv dt here now is where we apply the chain rule, which states that dy du dot du dt in this case is equals to dy dt out there. So from this, our v, which is cos pi t plus pi over 4 our y is equals to cos u, and our u is equals to pi t plus pi over 4. Okay, so finding dy du is equals to d cos u over du. When you differentiate cos, we get negative sign, so it will be negative sin u, and then du dt is equals to d dt of pi t plus pi over 4 pi over 4, so that when we differentiate pi t, we get pi, then when we differentiate pi over 4 is a constant, we get 0. So our answer here is pi. Are we together? So applying the chain rule, chain rule for, remember, is dv dt. So dv dt chain rule. So dy du is negative sine u dot du dt, which is pi. We get negative pi sine u, but u, remember, u is equals to pi t plus pi over 4. So this becomes negative pi sine pi t plus pi over 4, that way. So here this negative pi sine pi t plus pi over 4 is our dv dt. So our dv dt is negative pi sine pi, or we can write with this different ink, negative pi, or another ink, negative pi sine pi pi t plus pi over 4 plus pi over 4. So applying the product rule, applying now the product rule, u dv dt plus v du dt. Our u was 4, so it becomes 400 meters times dv dt our is negative pi sine pi t plus pi over 4. Then we add v. What was our v? Our v was cos pi t plus pi over 4 plus cos pi t plus pi over 4. There, are we together? Then we multiply by, that's v, we multiply by du dt, but du dt is 0. We multiply by 0, so that we get dx dt is equals to dx dt is equals to 4.00 pi meters per second. Remember now it is its velocity, since we have differentiated the displacement, meters per second, sine pi t plus pi over 4. Since these terms 0 is 0, and this becomes our velocity at time t, and therefore we have said that the velocity v at any time t is negative 4, yes, it's negative 4.00 pi meters per second times sine in brackets pi t plus pi over 4. This is what I'm saying, that v is given by negative 400 pi meters per second sine pi t plus pi over 4. For acceleration, since the question says calculate the velocity and acceleration of the wheel at any time t, we are done with the velocity. So for acceleration, we'll do the same as we have done for velocity. So we shall find the derivative of velocity. We will differentiate this. Are we there? The same process. So our velocity A will be equals to dv dt. Remember, v is the velocity with respect to dt. T is equals to negative 4.00 pi meters per second cos pi t plus pi over 4. After doing doing all this, as we have done for velocity, if we differentiate this velocity will get this acceleration. Are you there? You get this acceleration d dt by t. I don't want to repeat all that process, since I have shown you how to differentiate using product rule, both product rule and the chain rule, so you can apply the same for acceleration. Are we there? So that you have the final answer for acceleration as negative 4.00 pi squared meters per second square. Since it's acceleration, it's meters per second square, cos pi t plus pi over 4 plus pi over 4. And we are done with part B. Part C, using the results of part B, determine the position, velocity and acceleration of the object at t is equals to 1.00 seconds. 1.00 seconds. So for part C, we just substitute in the values of t. Where there is t, we put 1. Where there is t, we put 1. So if we start with the position which is x, the displacement x is equals to 4.00 meters. This cos pi t plus pi over 4. I'm saying for x, with the position is equal to 4.00 meters. Cos pi t plus pi over 4, we substitute t with 1. Since the question is asking us to determine the position, velocity and acceleration of the object at time at t is equals to 1.00 seconds. So x will be 4.00 meters cos pi, remember t is now 1, so it will remain to be pi plus pi over 4, so that we have x is equal to 4.00 meters cos 5 pi over 4, which gives us 4.00 meters times negative 0.707, which is the same as negative 2.833 meters. That's for position. Then velocity, the expression for velocity was v was negative 4.00 meters per second sine pi t plus pi over 4. So we substitute this t, we substitute t with 1, so that we have negative 4.00 meters per second. Sine, here it is 1 times pi is pi plus pi over 4. We have negative 4.00 meters per second. Sine 5 pi over 4. This gives us negative 4.00. Oh, here is pi. Sorry, it was pi. I think here we had pi here. We had pi. It's pi. So here is pi. Sorry, pi. Is pi also. So 4.00 pi meters per second. Sorry for that. I had omitted this pi. I had forgotten to write, but sorry, I've rectified. Then times negative 0.707, which gives us 8.89 meters per second. Then for acceleration, we have found v or a, acceleration a to be, our acceleration a to be negative 4.00 pi squared meters per second square cos pi t plus pi over 4. Substituting t with 1, we get a to be negative 4.00 pi square meters per second square so that we have negative 4.00 pi squared meters per second square cos, remember we have substituted t with 1, so we have pi plus pi over 4, we get 5 pi over 4, so that the final answer for acceleration at time t, when t is equals to 1.00 seconds, becomes negative 4.00 pi squared meters per second square. Are we there? Times negative 0.707, which gives us 27.9 meters per second square. Are we there? We are done. Part D. Determine the maximum speed and maximum acceleration of the object. Maximum speed and maximum acceleration of the object. Maximum speed and maximum acceleration of the object. Solution for part D. Remember, in the general expressions for v and a, for velocity and acceleration found in part B, the general, this one for v and this one for v and for v, where is this one for v, and for acceleration found in part B, we use the factor that the maximum values of the sine and cosine functions are unity. When we say unity, we mean 1 are unity. Therefore, v for velocity varies between, remember v varies varies between positive 4.00 pi meters per second and A acceleration varies between plus or minus 4.00 pi square meters per second square, and thus V maximum will be equal to 4.00 pi meters per second, which gives us 12.6 meters per second, and maximum acceleration A max will be equals to 4.00 pi squared meters per second, which gives us 39.5 meters per second square. We obtain the same results using the relations Vmax can also be given as omega A, and A max can also be given or found by omega square A, where A is equals to 4.00 meters and omega is equals to pi rad per second. But the answers for maximum velocity and maximum acceleration for maximum velocity is 12.6 meters per second and maximum acceleration is 39.5 meters per second square. Thank you for watching.